How JavaScript runs code before it even exists? You've seen it. JavaScript accessing variables before they're even declared. It looks impossible, like code defying the laws of physics. Is the engine secretly rearranging your code? Not quite. The truth is far more elegant. Welcome to the creation phase, where memory awakens before execution begins. Today, we're going deep. Variable hoisting, function hoisting, the critical differences between var, let, and constant, why function expressions break the rules, and the mysterious zone where variables exist but can't be touched. Hoisting happens before your code runs. During the creation phase, JavaScript's engine performs a scan, analyzing every declaration. But here's the key: the code never moves. Instead, the engine allocates memory slots, preparing space for what's coming. Variables get registered. Functions get stored, all before line 1 executes. Watch this mystery unfold. We log variable a before declaring it. No crash, no error, just undefined. Why? The creation phase already carved out memory for the slot exists. The value? That comes later, during execution. Remember the execution context. Every context operates in two distinct phases. First, the creation phase scans your source code, discovering variables, discovering functions, allocating memory slots, and preparing the environment. Then comes execution. This is where hoisting lives, in that critical first phase. Let's see it in action. We declare variable score and function calculate. Before a single line executes, the creation phase registers score in memory as undefined. Then it does something remarkable. It stores the entire calculate function body. Complete, ready, waiting. When the engine discovers a var variable, it acts immediately. Memory allocated, value assigned, undefined. The execution phase hasn't even started. Later, during execution, the real assignment happens. This is why you can access var variables early. Watch the transformation. First log, undefined, because assignment hasn't occurred. Then score receives 100 during execution. Second log, 100. The variable existed all along in memory. Only its value evolved from undefined to 100. Function declarations play by different rules. The engine doesn't just note the name. It captures the entire function body during creation phase. Every line, every parameter. The complete function becomes available instantly before any code runs. We call greet before declaring it. No error. The function executes perfectly. Why does this work? The entire greet function was registered during creation phase. It's been ready since line 0. The creation phase treats these three keywords very differently. Var gets initialized to undefined immediately. Let and const, they're reserved in memory but left uninitialized. They enter a restricted zone, a protective barrier. Access denied until initialization. With var, early access returns undefined. The variable was initialized during creation phase. No crash, no error. But with let and const, early access triggers a reference error. The variables exist in memory. The engine knows they're there, but access is blocked until you hit the initialization line. This protective barrier has a name, the Temporal Dead Zone. Function expressions look like functions, but they hoist like variables. Only the variable name gets registered. The function value? Not stored. During creation phase, greet becomes undefined. The function assignment happens later, during execution. Two separate moments in time. We attempt to call greet before the function expression. TypeError. The variable greet exists, holding undefined. But undefined is not callable. It's not a function. The function value hasn't been assigned yet. The temporal dead zone. It's the gap between memory allocation and initialization. Let and const variables exist in memory. The engine can see them in its records. But access is completely blocked. You cannot read. You cannot write. Until the initialization line executes. We try logging age before let age is initialized. Reference error. The variable exists. Memory is allocated. But we're trapped in the temporal dead zone. Access remains forbidden until the let age line executes. Let's connect everything. Source code arrives. An execution context springs to life. The creation phase begins its scan. Variables, registered. Functions, stored. Memory, prepared. Then the execution phase takes over, running your code line by line, assigning values, calling functions. 2 phases. 1 seamless system. Hoisting isn't magic. JavaScript never rearranges your code. It simply prepares memory during the creation phase, before execution begins. Var becomes undefined. Function declarations are fully stored, ready to run. Function expressions behave like variables. Let and const enter the temporal dead zone. Now you see the system. The engine's elegant preparation dance. This is hoisting.